हेलो फ्रेंड्स। उम्मीद है आप सब खैरियत से होंगे। आज हम पढ़ने वाले हैं केमिस्ट्री आधे घंटे तक लगातार। देखते हैं क्या हो पाता या नहीं। उफ, the Avogadro numbers in a chemical reaction. Large number of atoms or molecules of reactants react to give like tone on the mass showing turns reacts for this purpose. Tens in grams. To achieve this object, we need to transform the concept concepts which may measure and compound. These are basic for the multiplier. Avogadro number after the name of an Italian chemist. Lodo Avogadro of a substance is called is respected as yeah. Chemical change into reaction representing a chemical change in this way is called chemical equation. To understand a chemical change and to study different factors which role it has always been a focal point in the efforts of chemists to achieve these objectives. We should have an appropriate way to presenting a chemical change. Fortunately, the chemists have developed very suitable in chemical change. In this way, the chemical equation. A chemical it tells us the chemical compounds which are reacting and those which are being produced as a result of chemical change called products. Here the cutter. If a reaction is accompanied with the evolution of heat, it is called an exothermic reaction, and if heat is observed during a reaction, it is called an endothermic reaction. reaction is a compare with the evolution of heat called exothermic reaction, endothermic reaction. Energy we not only encounter heat which comes out of a chemical reaction but also we not only encounter heat content as defined as the total amount of thermal energy stored in a compound. The unit of its measurement is kg mole. System enclosed when energy is evolved during a reaction. Total enthalpy of the system decreases. Chemical energetics is part of a broader field of chemistry called thermodynamics. In chemistry, any physical or chemical change under study may also be called a system. Enthalpy, the total amount of heat energy present in a molecule under standard conditions. Their temperature and Celsius is also called its heat content. Enthalpy is a measurement of energy in a thermodynamical system. The quantity of enthalpy is equal to the total heat content of a system. Enthalpy of a system is represented by H, while the change in enthalpy which a system undergoes is represented by this. The enthalpy of a system cannot be measured directly. Relatively easy. How does a reaction take place? A reaction takes place when the reactant molecules collide with each other to give a transition state. Let us study the following hypothetical reaction. Before mixing, the molecules of a reactant A and B are in a state of random motion, separately colliding with each other and with the walls of container. This molecule possesses average kinetic energy, but a few possesses more than average energy, while yet other passes less than average. Well, and also we call excited molecules, etc. Yeah, exothermic reaction. Yeah, endothermic reaction. The process of respiration in human beings is a continuous process. During this, we breathe in oxygen and breathe out carbon dioxide. Respiration also carries complex chemical reactions inside the human body. This process occurs in the presence of oxygen, which is called respiration. Aerobic respiration is an exothermic process and involves the following reaction: glucose C6H12O6 in high in cytoplasm C3H4O3 2 pyruvate plus energy O2 in mitochondria 6CO2 H2O L plus energy glucolyze. During glycation, one molecule of glucose is split into two molecules of pyruvate. This process involves a series of reactions that are released by enzymes with the net production of 2 ATP. Tryptophan. When cells of our body require energy for performing the metabolic activities, the use of this ATP and break it down to get the required energy. The food we eat undergoes digestion in our body and digest food molecules that are absorbed by the cells under oxidation to produce energy. In certain organisms like bacteria and algae, this respiration occurs in the absence of oxygen and it is called anaerobic respiration. This is also exothermic process and during this process glucose is converted into carbon. In chemical reaction, the reactants react to give the products. The reaction will continue until all the reactants or one of the reactants is converted into products. The following reaction takes place immediately in aqueous solution to give the products. Give the product. The reaction goes to completion and if COH stoichiometry amount of reactants are used, then no reactant species are present. It is called an irreversible reaction. It moves in the form direction only. In the majority of chemical reaction, however, the reaction does not go to completion. The product of the reaction react among themselves to give back the reactor under the same conditions. Such a reaction moves in both the forward and backward directions under the same conditions. The reactants react to give the products and the products in turn react to give back the reactants. If a reversible reaction is started by mixing the reactants, the reaction moves in the forward direction only after some time when enough concentration of the product are built up. They react to give back the reactants. In the reverse reaction, the reaction will keep on going in both the direction until the rate of forward reaction becomes equal to the rate of backward reaction. In other words, the number of reactant molecules will disappear as a result of forward reaction becomes equal to the number of reactants molecules which will form as a result of the reverse reaction. The same will be true for the product molecule at this stage. At this stage, the reaction is said to be a state of chemical equilibrium. It appears as if nothing is going on the reaction, visual as the concentration of both reactants and products. Reactant and products. Reactants and products molecules do not undergo any change at this stage since the reaction did not cause at this state of equilibrium, rather it keeps on going. Mm, N2O2. Acids and bases. There are acids have been known for their sourness, like the taste of lemon and ability to change the color of litmus paper from blue to red. There are many substances which contain acid and hence taste so such as curd, tamarind, lemon and lime etc. Common examples of acids include acetic acid. Acids are divided into two types. Acids which are obtained from natural sources are called natural or organic acid. Mineral or man-made acids are prepared from minerals like sodium chloride or sodium nitrite. Acetic acid, vinegar, ascorbic acid, amla, citric acid, lemon, lactic acid, milk, curd, formic acid, and tin, oxalic acid, tomato, tartaric acid, tamarind, and bases are known for their bitter taste, slippery touch, and ability to change the color of litmus paper from red to blue. that dissolve in water. Arrhenius acid and bases. Arrhenius a Swedish chemist suggested that behavior in water, according to him, an acid is that substance which dissociates in water to give proton or hydronium ion. Some typical Arrhenius acids are HCl, HNO, H2SO4, and HCN. Transcendental concept. Arrhenius concept of acid and bases is very simple and easily understandable, but it has its own limitations. For example, Na2CO3, K2CO3, and NH3 do not contain any hydroxyl group, which will get ionized by water, but all these compounds behave as bases and yield OH- in water. Arrhenius definition also requires that water must be present as a solvent in order for a compound uh, to behave as an acid or a base. It was released that a board was released that a broader definition for acids and bases was needed to cover all the aspects of the concept. An acid is a substance that donates a proton, and base is a substance that accepts a proton. Amphotericity, amphoteric compound, which means compound that can be seen in a base. Formic acid. The horizontal rows in the modern periodic table are called periods. There are 7 periods in total. Each period except the first start with alkali matter and end at a noble gas. Each period also represents the completion of a shell. The number of elements in period is also fixed. The detail about the period. 6, 7 period, two series of 14 elements which have been accommodated because of the space problem. These two series were placed at the bottom of the periodic table to keep it in a manageable and presentable form. The first series starts after lanthanum and it is called lanthanoids. Starts after actinium and it is called actinides. Together, the elements present in these two series are also called rare earth or Haploid elements. Vertical columns present in the periodic table are called groups. There are in total 18 groups. The elements present in a group resemble one another in their chemical properties since they contain the same number of electrons in their outermost shell. Elements present in a group are also called a family, and each group has also been given a family name. The distribution of elements in the outermost shell, electronic configuration, and the other. All the initial are completely found in element, and in the element the subshell are in the process of completion. Elements present in the periodic table are also classified into blocks. Subshell which is being filled as PDF, and because properties of group element 1. Elements present in group 18 of the modern periodic table are called noble elements. All noble elements are monatomic gases having very low boiling points. Helium, neon, these gases have 8 electrons in the outermost shells, except helium, which has 2 electron configurations since the outermost shell are completed. They show very little chemical reactivity. Group properties of transition elements. Elements present at the center of the modern periodic table. Twelve are called B block elements or transition elements. All transition elements are metals having the similar properties. Transition elements are often hard with higher density. Their melting and boiling points are also high. These metals show variable oxidation state and become found often color red. Properties of group 17. Properties of group 1 element. All the elements present in group 1 have an S1 configuration in the outermost shell. They are also called alkali metals. Their single electron can be removed easily, which makes these metals very reactive, except the most element, except the first element, hydrogen, which is also a gas and a non-metal when removed top to bottom. In this group, the atomic mass size increases owing to this. It becomes easier for elements to lose electrons down the group, which is reflected in the increased reactivities. Lower member of group lithium react with water steadily, leaving hydrogen and lithium. Right. Sodium reacts vigorously while potassium reacts violently with water, giving their respective water salt hydroxides. Two H levels to H2O. Increase in the atomic size down the first group also weaker mass interatomic. फाइनली आधा घंटा कंप्लीट हो गया है और अब खाना खाते हैं, खाना खाने के बाद पढ़ते हैं।